So, hello student, today we are in the last lecture of biological treatment first that is on composting, and in this lecture we will talk about vermicomposting. So, this is also another method of composting. Normally we believe that this is a vermicomposting is specially for the degradation process by the earthworms, but also there will be a role of microorganisms also like bacteria and other microorganism like in the conventional composting process also, that also is very required for the degradation process. Okay. So, many time when you talk about type of composting, so normally people will say that agitated pile or aerated pile, in vessel composting, we will finish that, and vermicomposting normally discuss in the separately, but also you can consider vermicomposting also is one type of composting process. Okay. But as the name suggests is a vermicomposting, so is completely depend on the earthworms. Okay. So, the vermicompost is a product of decomposition process using various species of the worm. Usually I think major one is a Acinetobacter foetida, that is normally we call as a red worms, okay, and another white worms. This is also other earthworms that create a mixture of decomposition of decomposing the vegetable food waste or different kind of organic waste is possible to degrade. Here need to be understand that all kind of earthworms can't be able to degrade the organic waste, like you see in the rainy season, you will see most of the earthworms you will find in the soil. Those soil earthworms can't degrade the organic waste, because the organic waste is producing odor also, leachate also the excess water, that these kind of earthworms like soil earthworms can't be possible to live into those conditions. Okay. And normally this word also will come up normally when you talk about vermicast, that this is the final product we are getting it from the vermicomposting process. This is normally is a vermicast means is a worm casting or worm humus or manure or feces, that is called as a vermicast. Okay. That is the end product is coming out from the vermicomposting process. So, many time people will say is a vermicomposting process, and the product rather than calling as a simple compost, we will call as a either vermicompost, or many time or many books or literature you will say vermicast, both are similar one. And this vermicompost contain water soluble nutrients and is a excellent nutrient rich organic fertilizer and soil conditioner. Okay. See, this is what the somewhat difference from the normal compost. So, here is a water soluble nutrients are available. Okay. So, means I think most of the nutrients also the amount will be high, and also it will be very easily water soluble. So, you see that the major earthworms normally done the research for the vermicomposting process, that is Acinetobacter foetida. So, this is the Acinetobacter foetida, and here you can see the intestine is one of the best intestine is found, where not only the organic waste is getting degraded very easily, but also suppose the organic waste is having high metal content like sewage sludge, water hyacinth, the different weeds, these metal also will be in the intestine. So, in the final cast the vermicast the metal won't come up. So, normally in the composting process the metal content is increasing, but in the vermicomposting process the metal concentration will decrease because of the earthworms intestine. This is the what is a exact photograph of earthworm Acinetobacter foetida. This is a red one, and another the white worm. this is the white one. But I think we do not find lot of research for white earthworm, but we will find lot of literature for degradation of various kind of organic waste, which is including agriculture waste, municipal waste, industrial waste. Also the lot of studies are available, and this is a few different technology, or rather than technology, different ways the vermicomposting is possible. Like the first is a cow pit. So, this is the cow pit where the cow dung along with the earthworms put it into this pit, and this earthworm will degrade the cow dung. Similar, this is a vermi wash. The similar way, in the degradation process, because lot of water will get produced. So, this whatever the water will come out, that we called as a vermi wash, and this is the very well known process in the 90s. The most of the in the rural India, we find this NADEP composting method, composting system. So, it is a very simple for construction also, and in this one the waste is getting disposed along with the earthworms. Okay. And within 45 days, within 60 days, the entire degradation will be possible. So, the one major benefit of vermicomposting process is not only the degradation, but also their population also will increase. So, means I think once you are having suppose 500 or 1000 number of earthworms, you need not to purchase afterward, because the same the 500 or 1000 earthworms will increase in the maybe 10,000, maybe it goes to 50,000, and again I think we can continue the similar process. Also we can sell the compost, and also we can sell the earthworms also. So, it is a highly beneficial method. So, what is the mechanism of vermicomposting process? Is a similar kind of composting process like biodegradable material. Here also we required homogeneous mixing, especially the brown waste and green waste should be properly homogenized, mixed is required. So, during the vermicomposting process, we will put worm biomass, and will be required, obviously will be required oxygen, also the water will be also required. Okay. But if again the same discussion in the previous class, if you have more water content like 95%, 100%, so obviously the earthworms won't get it the oxygen very properly. So, in the voids you will be required moisture, but the complete moisture, if entire voids will be filled by moisture, again the condition will be anaerobic, and these earthworms can't be live in anaerobic condition. And finally, we will get few gases, okay, and as a product we will get earthworm cocoon harvesting, and this we have to segregate first, and finally we will get very good quality vermicompost. So, which I was telling that we will get the population of earthworms also will get increase, and their cocoons also will increase. So, first we have to harvest those earthworms or cocoons, and then whatever is remain that will be a vermicompost. Now, worms in vermicomposting. So, normally there are 3 different type of earthworms normally getting used in the vermicomposting process. First is the Anaceacic, and this is not very well known one, and still not much studies are available for this kind of earthworm. Okay. So, here is the clitelium from where the cocoons will get produced. So, these kind of earthworms build a permanent burrow in the deep soil, drag down their food from the soil surface to their burrow, and finally, it will come as a finished product. So, now this is the important one, endozoic earthworm. This is also the lot of studies are available on these earthworms also. So, this will build burrow on upper layer of the soil and feed on organic matter and mostly visible in rainy season. Okay. So, here see idea is that it will be burrow on upper layer of the soil. So, suppose once you prepared any bed for degradation process, obviously we will put the waste here and here suppose these are the earthworms. So, they will burrow onto the top, they will degrade the upper location and again they will go in the bottom. So, we can collect, we can harvest the compost and again we can put the fresh waste. That is what the benefit of this kind of earthworms. So, continuously we can work for the vermicomposting process. And this is the well known epizeic, that is the Acinna foetida which we saw in the previous slide. This will feed on the decaying organic matter, do not form burrow and useful for vermicomposting process. So, I think most of the studies are available on the epizeic earthworms and the major on Acinna foetida. This is now the 3 different kind of epizeic earthworms, where based on the parameter we can compare like duration of life cycle. So, this is the local earthworm, like we can say is a Indian one, we can find very easily, Puranix. Okay. The growth rate also you will see the maximum is available here, maximum growth rate, and incubation period also here 23 days, and cocoon production is also very high here, and the number of hatchings per cocoon here I think is almost same in both the one. So, when you compare that the different earthworm species, I think Acinna foetida is well known and well popular. This is also another one more table where the suitability of earthworms for various kind of waste, like for Acinna foetida you will see here, for Acinna foetida the fly ash, sewage sludge, waste activated sludge, various kind of sludge, various kind of cattle dungs and even the kitchen waste, the MSW, the biogas slurry, this all could be possible. Even I think this is one, the Indian one I was talking, Puranix, which is specially for the cow dung, and there are other earthworms also which are possible to use for the MSW, like this earthworm, this is also for MSW. And because see, when you say the organic waste is not only the MSW organic waste or municipal solid waste organic waste, there are organic waste is coming from the agriculture area, sewage treatment facility, the organic waste will coming from the industrial area. So, the different earthworms will be useful for the different kind of organic waste. Now, there are some silent requirement of the vermicomposting process, like there are basic requirements or you can say that there are number of factors are affecting the vermicomposting process, like suitable bedding, which I am going to talk again. I think it required the special kind of bedding if they do not like to eat the material, eat the organic matter. So, you will be required suitable bedding, food source, the proper kind of substrate is required, adequate moisture is required for the degradation process, adequate aeration is required, suitable temperature, this is also very important one. Because see, the earthworms also are live conditions. So, obviously, in the colder condition, like when the ambient temperature is 5 degree, 10 degree, difficult to have the growth into their population. If there is no growth, even the decomposition or degradation also won't be that fast, and suitable pH. This is also very important one. So, all the for vermicomposting process, neutral pH is very basic requirement for the degradation process. Now, we will go for one by one. So, the bedding is a material that provides a relatively stable habitat to the worms. So, normally in a reactor or anywhere, if you are going for a vermicomposting process, you need to put first the bedding. So, the idea of the bedding to provide relatively stable habitats to the worms means because see earthworm also required the acclimatization for that particular kind of organic material, and for acclimatization at least that 7 days or 15 days will be required for the acclimatization in that particular organic material, or maybe time to time you can change the organic matter also, or suppose if you are starting with the one particular kind of organic matter, acclimatization will be always required. So, during the acclimatization period, how they can be in the live condition, because they have to particularly acclimatize that condition. So, they will be required the special kind of the bed, so that in that bed they will be in the live condition, and once they will be acclimatized, they can go and they can degrade the organic matter, whatever the organic matter we are supplying for their degradation process. So, what kind of bedding will be required? First is the high absorbency. As earthworm breathe through the screen, the bedding must be able to absorb and retain adequate water. See, as worm breathe through their skin, the bedding must be able to absorb and retain adequate water. So, obviously water will be required, okay. And good bulking potential, the bulking potential of the material should be such that worms get oxygen properly, okay. So, now is also very important point that, so you can't have the much depth of the reactor, because your oxygen is required. Either if you are increasing the depth, means you have to have the some kind of opening in the bottom, so that the air can be enter into the bedding material, and low nitrogen content and high carbon to nitrogen ratio. High protein nitrogen level can result in the rapid degradation, and associated heating may be fatal to the worms. See, whatever the bedding material you are using, this bedding material should have low nitrogen content. Why? Because if suppose there is a large or very high nitrogen content will be there, then obviously the nitrogen will degrade or will create some gases, because the degradation will be there obviously. So, either heat will be get produced, or some odorous gases like ammonia will get produced, and they do not like the odorous gases like ammonia or H2S. If there is a odor, then their growth will be completely fatal for the worms. So, these are the some bedding materials, common bedding materials we are using, and mostly cases I think you see the dry leaves we are using, some trimmings, even sawdust, corrugated cardboard, even newspaper, paper from MSW, even some kind of different manures also, or different cattle dungs also we can use for the bedding material. So, here it has been compared these different bedding material for their absorbency, means absorption of water, bulking potential, and carbon to nitrogen ratio. So, you can see here I think the bedding material like dry leaves, sawdust is somewhat good, even the bark softwood is also good bulking potential, carbon to nitrogen ratio is also high, but most of these materials are very poor in the absorbency. Because of that, if you are using any kind of bedding material, you need to add more amount of water, and not only the more amount of water, but also continuously you have to add the water. So, that because the absorbency is very poor, so the time to time you have to add the water for the degradation process. If available, the shredded paper or cardboard makes excellent bedding, particularly when the combined with the typical on-farm organic resources such as straw and hay. I think this is one more important point. You can use as a shredded paper, cardboard, or if you are doing the vermicomposting at farm itself. So, why not the other organic resources like straw, hay we can use, and also we can add this kind of material with prepared compost. So, that the water absorbency also can be increased. Now, the next point is the food source. So, regular input of feed material for the earthworm is most essential step in the vermicomposting process. Earthworm can use wide variety of organic material as food, but to exhibit food preferences. Under ideal condition, worms can consume amount of food higher than their body weight, but general rule of thumb is consumption of food weighing half of their body weight per day. So, you see here the under ideal condition means what could be the ideal condition, that pH is neutral, moisture is very good, the proper optimum moisture is there, and whatever the substrate has been added, that substrate is not producing any kind of gas, and not possible to increase the temperature in the degradation process. So, this is also one important point which I am going to again discuss about that. So, once this wet waste will get degraded, obviously the temperature will increase. So, that is not good for the vermicomposting process. So, if in the reactor the ideal condition could be possible, then the earthworms will eat more than their body weight, but normally or as a rule of thumb, how much amount of earthworms need to be added into that particular reactor or particular system. So, that is based on this information that, so every earthworm will eat half of their body weight per day. So, by that way we can also fix the time of vermicomposting process, and also we can put that number of earthworms for the degradation process for particular amount of organic material. In adverse condition, earthworms can extract sufficient nourishment from soil to survive. See, any live material or any live cell will try to be in the live condition. Nobody wants to die very easily. So, even earthworms also, very adverse conditions also, they will be trying to in the live condition and trying to degrade the organic material. Like take the example of this Hesina fetida. This is normally is not the Indian one. This is the European earthworm. It has come from the European. So, you see the ambient temperature in the European country. Their local conditions are different. Ambient temperature never reach to 25 to 30 degree. So, that same earthworm now we can easily find in the African country, in the American country, even the same earthworm we can find in many locations in India. Even in India, the climatic conditions in the central part of India or central India like Nagpur and Madhya Pradesh kind of area where temperature is very high, there also you will find the Hesina fetida. And if you come to the northeast India where temperature is very low and mostly in the rainy season, almost 6 months, 7 months rain, still we will find this Hesina fetida. So, means you see their survival in very diverse condition and very adverse condition also are possible. Now, next point is a moisture. So, the most important requirement of earthworm is adequate moisture. So, they required almost 60 to 70% of nitrogen, and the feedstock should not be too wet, otherwise it may create anaerobic condition which may be fatal to the earthworm. Next is the aeration. So, the factors such as high level of fatty or oily substances in the feedstock or excessive moisture combined with poor aeration may render anaerobic condition in vermicomposting process, and worms suffer severe mortality partly because they are deprived of oxygen and partly because of toxic substances produced under such condition. So, aeration is also very important. So, now I think we talked aeration in conventional composting process, even in the in vessel composting process. That aeration not like in the vermicomposting process. If you turn the entire reactor for aeration, I think I do not see that the earthworm will be beneficial because of that. Now, because of that, just for the aeration process, we should not go up to the large depth. So, normally I think some research share this, the depth should not be more than 500 centimeter. I think that is very small one we can get, because until that the aeration could be possible, and also any reactor should be some openings from the other part of the system or other part of the reactor. So, that air can be sufficient, air can be inject into the particular system or in the reactor. Next is the temperature. The activity, metabolism, growth, respiration and production of earthworm are generally influenced by the temperature. Worms have a optimum temperature range of 16 to 25 degree centigrade, but temperature above 40 degree centigrade can kill earthworm. So, this is the problem or maybe is a good climatic condition they can find in the European country, even in the India also. I think except the summer we will have this kind of temperature. So, for India or South Asian countries, we need to see that how these earthworms could be possible to work into the winter condition, where temperature lower than 10 degree. So, there could be also possible that could be some kind of mortality we can find, and where the temperature is more than 40 degree, that is possible in most part of India, like in the central India, South India or in the North India also the temperature goes to 42, 43 or even 48 degree temperature. So, there the mortality is possible, but again I am saying that this Acinetobacter foetida is I think is very highly survival earthworm, and there are some studies are showing that this earthworm is possible to grow in 0 degree to 2 degree centigrade. I think there are one study shows in the Shillong in northeast, where temperature reached to 0 degree or 2 degree centigrade in the night. Still the earthworms were in the live condition. Obviously, there will be some kind of mortality, but the parallelly the growth will be also there. I think the cocoon production is not that large, but the cocoon productions will be also possible in that condition. Even some studies conducted in the such part of India, where the temperature rose to 45 degree centigrade, there also we find some mortality, but the growth is also possible. So, in that case I think we need to see that how best we can optimize the other conditions like moisture, substrate, aeration. If we can have the optimum condition for their growth, so we can easily reduce the mortality of the earthworms. Now, is another one is pH is one of the important factor. The worms can survive in pH range to 5 to 9, is a large range, but if it is a range of 7.5 to 8 is considered to be optimum. In general, the pH of worm beds tends to drop over time due to fragmentation of organic matter under the series of chemical reaction. So, now the problem is our kitchen waste in MSW is highly acidic in nature. So, their pH goes to 4, even 5. So, that pH is not good for the earthworms. So, that is why I think in the conventional composting also I discussed about that if you mix different kind of material like brown waste, green waste, or the dry waste and wet waste together, like kitchen waste if you mix with the agriculture waste. So, obviously a carbon to nitrogen ratio also will be changed, and obviously it will affect the pH also, or because of this pH issue or the high degradation of kitchen waste, this is also proposed by many studies that in the fresh kitchen waste do not apply the earthworms. What this research says that if you have only kitchen waste for the degradation process or vermicomposting process, so you allow that particular material for 15 days for self degradation process. So, up to 15 days this green waste will convert into somewhat brown color, means the normal degradation will be there, and whatever heat is producing by the degradation process, that heat also will get removed out. I think the thermophilic condition will not come up, but temperature more than 40-45 degree also, that also will be come out, and then after 15 days now you apply the earthworms into the degradation process. That become actually one of the negative point of the vermicomposting process. So, there are many studies, I think there are hundreds of research journals says that the earthworm should not be applied into the fresh material. Only the problem is that because that organic material will go for thermophilic conditions, or the temperature will increase, and because of that high degradation process the odorous gases will produce. Because of that there could be a mortality of the complete mortality of earthworms, and some studies says that the entire the 100% mortality was found if you are applying the earthworms into the fresh material. So, but I think again if you mix the proper kind of material, proper mix of the material if you make, that is possible to have the proper pH, and even we can apply into the fresh material also. Other important parameters like the pre-composting of organic waste, it is established that pre-composition of organic waste is very essential to avoid the mortality of earthworm. This is what I was talking about, it will be required the pre-composting of organic waste. So, I think some research says that why not this vermicomposting can do after the in-vessel composting process. So, in-vessel process means rotary drum composting process. So, in the rotary drum, like in the previous class I explained about the rotary drum composting for only 7 days, and there also you are not able to find the matured compost. So, in the same compost if you do that maturation by vermicomposting process, that will be highly beneficial process. Even the salt content, worms are very sensitive to the salt. So, that also need to be see that urine content or other toxic components is also important for the growth of the earthworm, and deworming medicine in manures. And also the I think these are the some important parameter also need to be look upon during the vermicomposting process. So, this is how to build a worm or how to build a worm home or vermicomposting process. So, here you will see this one particular bucket where we can make this bucket itself as a vermicomposting reactor or worm home. So, you will see here in the bottom is a bedding material in the bottom, followed by waste and earthworm mix, and in the top we put it gunny bag, gunny bag to retain the moisture, because moisture will get evaporated. So, the upper surface will be dry. So, the degradation will not be possible in that case, and also they do not like the light, especially the epigeic earthworms do not like light. So, the maximum degradation will be in the upper surface, and maximum degradation will be into the night time, where there will not be any light. So what they will do, in the night they will come onto the top, they will degrade the material, in the morning they will go into the bottom. Okay. So that is why if you put some kind of cover onto the top material, and here I put it the gunny bag, because gunny bag also we can add the time to time water, and we can make entire reactor proper moisture we can attain. So worm need air to survive, they can live in the plastic bin or wooden box with several air holes punched or drilled all around. So this is the holes. Okay. This is for aeration process. Okay. It is more convenient to have several smaller or more portable units rather than one large one. So, okay. Do not use a bin that was once used to store chemicals such as pesticide, and or you may end up with a pile of dead worms. Vermicomposting container box should be shallow and wider than it is tall. So, container box is shallow and wider than it is tall. So, you can see here the average size of vermicomposting bin for household of 2 people should be a 30 centimeter high, 40 centimeter deep and 60 centimeter long, if you are using in the household area. So, this is what the unit could be possible, that it should be a tall, upper area will be more compared to the bottom area. So, this is the household vermicomposting reactor. So, here 3 units, first, second and third. Commercially these kind of units are available. Now, the vermicompost system, when you talk about the types or different way of vermicomposting could be possible, like windrow, wedge, or is a similar kind of windrow system, only modified one, beds and continuous flow through reactor. So, this is the windrow vermicomposting process. So, this is what the windrow is, a covered and wedge composting also is a modified one, but is a similar kind of windrow composting process. So, here the harvesting also is one of the important issue. Okay. So, now is a bed system. So, is a bed completely. So, is a difficult to harvest. So, now here earthworm has to be harvested for collecting of vermicast or vermicompost. Problem with too much moisture and low temperature. This is another photograph from Korea, where 10 tons per day sewage sludge, all harvesting done by hand with basket and racks. So, 18 employees are working regularly for harvesting of earthworm. Now, is a continuous flow through reactor. So, these kind of reactors also, though continuously we can add the material or organic material for the degradation process. And when you again compare, or when you talk about the different type of vermicomposting process, so is based on the scale, large scale, where the quantity is 250 kg per week, medium is 250 to 20 kg per week, small is less than 20 kg per week. So, for large scale is a windrow, medium scale continuous flow, and for small scale we can go for simply that tray, stacking, batching or wedge method. And in the last lecture I was talking about decentralized composting process. So, with this small scale also we can go for decentralized composting process, especially this we can do it in the even apartment area also. We can have the one vermicomposting unit, small vermicomposting unit, not in the household level, but in the community level also is possible. Or some of the community, if there are some particular locations available in particular community area, or some parks are available. So, in that parks we can create one vermicomposting bed or vermicomposting pit we can create, and all organic waste we can add along with the kitchen waste also for MSW also, and even the in the horticulture area the lot of organic waste is generated, that also we can utilize in the vermicomposting pit. So, it is a large continuous flow through reactor. This is also another unit. This is the, I think you can see is a long pits or vermicomposting. Vermicomposting in a large scale. So, you can see here the large units. This is all Indian way of vermicomposting process. So, this is what the vermicomposting units in this Indian Veterinary Research Institute, Bareilly, they are also doing in the Vidro based. So, here the water pipings are available and is the time to time is getting covered also. This is in the Divya Nursery, Haridwar, also working on vermicomposting process. This is the batch type vermicomposting system. So, you can see here in the bottom openings here have been created for the aeration process. This is the track or tray or stacking vermicomposting system. So, here also we can see that how the vermicomposting can be worked into the particular reactors, small reactors. So, here is a stack based reactors. Now, location of worm bins, like worm bins can be located in the number of places such as kitchen, basement or backyard. It is important to allow air to circulate through the bin by leaving the air holes uncovered. Feeding worms or worm food, an optimum carbon to nitrogen ratio of the order 30:1 must be maintained. I think this is important for the degradation process. If we are able to achieve carbon to nitrogen ratio 30:1, any fruit or vegetable waste generated during the food preparation can be used. Citrus peels, coffee ground and tomato can be added, but only in the moderation, as they can acidify the bedding. So, this also need to be looked upon, that if you are using for any fruit material also, if it is highly acidic and has to be mixed properly. So, adding dried crushed eggshells will help to control the acidity and will also provide the worms with valuable nutrients. A blender works well, however, cutting or mashing of the food scrap will do. So, the size is also very important for the degradation process, like same in the conventional composting process or in vessel composting process. So, if you are using at household level or in the small apartment level, so I think and whatever the waste we are applying for the vermicomposting process has to be put it into the blender or particular mixture or one particular shredder, where the size also can be homogeneous material can be created to supply for vermicomposting process. So, now this is for harvesting of worms. So, now this entire prepared material prepared compost will have the earthworms also, and we have to harvest that earthworm. So, there are two methods, by that way we can harvest the earthworm. By this is called light separation method. Simply you put one light, so is not only light, but also some heat is also generating by that particular light. Okay. Means I think 1 degree change in the temperature. So, because of that what will happen? So, all the earthworms will be in the bottom, okay, and remaining part you can collect it properly, okay, and finally we will get bundle of earthworms. and that will take maybe half an hour or 1 hour we can put under the light. So, normally in the laboratories they are using 60-watt bulb for harvesting of earthworms. This is for the small scale we can use, but for commercially or commercially running vermicomposting plants we can use worm harvester. This is the simple the filter where size is 2 mm to 4 mm. So, that only the fine particles will come out and earthworms we can easily collect or easily harvest from such kind of harvester. Now, what are the advantages of vermicomposting process? Is a labor and equipment cost is minimal. So, like we have seen the conventional composting process or in-vessel composting process is manpower requirement is more and lot of maintenance issues are there. So, here labor equipment cost is minimal. One of the promising decentralized composting technology, excellent composting concept for smaller community that required a rapid and enclosed pathogen kill process. It can be very useful in peri-urban areas of large cities, institutional area, vegetable market, large dairies along with the nursery and demand driven places like garden, parks, official area. So, likewise see in any city we will have lot of institutions. So, is a government institutions, civil offices, schools, colleges, hospitals, park, garden and different small units that we can say is a point sources of waste generation. So, in these particular location if you are using the vermicomposting process is a highly beneficial. So, your collection also will reduce in that case and these kind of material will not go to the disposal area. Worm casting improved the plant growth, earthworms double their population every 4 months. So, it is a highly beneficial one and when you compare with the conventional compost and vermicompost, so obviously the vermicompost quality is far better than the conventional or in-vessel composting process produce. Not only the nutrients, but lot of microbes also is highly beneficial microbes will be available in the vermicomposting process. So, like I was talking about the nitrogen content in the conventional compost can go up to 1.5 to 2% if you are using in-vessel composting process, but in vermicomposting there is always chances of getting 3.5 to up to 4.4% of nitrogen also could be possible to achieve in the vermicomposting process. And commercially if you see or as per the market you will see we can easily sell this kind of vermicompost at a cost of 30 rupees, 40 rupees per kg, whereas the conventional compost can go up to 5 rupees or 10 rupees per kg and that is why is a lot of advantages of vermicomposting process. Even the farmers along with the vegetation growth or along with that agriculture growth, they can also work parallelly with the production of vermicompost. So, that they will be highly economically beneficial for the farmers also. And the disadvantage like initial cost is high. Initial cost means only the construction of the pit or the preparation of that particular system and the cost of earthworms. These normally earthworms are available in our state agriculture board or agriculture department. They will have the earthworms and even the any farmer they want to go for vermicompost production, they can go to the agriculture department and they will get 100 or 500 numbers of earthworms and the cost will be around 50 paisa or in a 1 rupees you will get 2 numbers or 3 numbers, they will not count it, but the one particular quantity, if you pay 100 rupees, they will give 50 or 60 numbers of earthworms. So, it is not that very high cost, and the time requirement is more obviously as compared to the conventional composting process. So, like I was talking about in-vessel composting process, where degradation in 7 days or maximum 20 days is required for the degradation process, but for vermicomposting process, because it is a slow degradation process. So, we will require 60 days, 90 days for the degradation process, but addition of more earthworm and having the optimum condition for the degradation process, it is possible to finish the vermicomposting process within 30 days, 25 to 30 days. Still, this is a large compared to the conventional composting process. So, the troubleshooting could be possible, like I come up with few questions along with their answers. Like problem could be the bin has more food than bedding. So, what could be the solution? Do not add any more food for a week or 2. Suppose if you find that more food or more substrate has been added into the reactor or in the bin. So, in that case do not add food for a week, 1 week or 2 week. The problem could be the bedding is too wet and compacted. Okay. So, what could be the solution? Gently stir the entire content to allow more air in and stop adding food waste for a week or so. Make sure that your food waste is still buried. Okay. So, gently stir the entire material, so that air can supply into the material. The lid can be removed or left slightly to allow the content to dry out. Okay. The another problem could come up that the bedding is too acidic, causing the earthworm to crawl through the hole of the bin. So, whatever the opening has been given for the aeration process, it is possible that earthworms will come out from those openings. So, that is possible when the bed is acidic. So, what could be the solution? Add eggshells and cut down on the amount of citrus peel. So, means the citrus peel do not add for a week or 2 weeks. Tomato, coffee ground or other acidic food waste do not allow to add into the that particular bed. So, that by that way we can reduce the acidity of the particular bedding. So, here we saw that there are a lot of advantage of vermicomposting process, but the scale is only the major issue. One very important issue here, the scaling, how big we can go. So, when we were comparing about conventional windrow composting process, which can accept the 200 tons, 300 tons waste in a day, but we can't allow this much amount of waste in the vermicomposting process. In that case, you will be required large area, will be required large number of earthworms will be also required. So, that is what this vermicomposting facility can be easily possible to do it at household level or community level. So, as per the previous lecture, I was talking about and I was focusing on decentralized composting process could be highly beneficial for India or Asian countries or developing countries. So, in that case, along with the in-vessel composting process, we can also go for vermicomposting process also, because in-vessel is somewhat difficult at household level, but vermicomposting process can work for household level also, or by mingling of both the process together, we can work at the community level or at apartment level or at household level also can be worked. So, thank you.